Hello guys, welcome back to Daily Coding. Today we are going to discuss about valid mountain array problem. So let me explain what is valid mountain problem. So here we can see. So this is the array. Suppose we have the array. Let me clean first and then we'll try to explain it again. So let me clean this all. So what is the valid mountain? So suppose we have the array. This is the array. Our array is 0, 3, 2, 1 and we defined here. So initial value 0, it is on the bottom and then it's increasing. So 0, it's became 3 and then it started climbing down, it started decreasing 2 and then 1. So this is forming a mountain. If it should be something like that, suppose this value is 4, here 2 and then the value here is 1. This is the only array. We don't have other than that, like arrays 4, 3 and 2 and 1. This is not forming a valid mountain. It's just a sloping. But if our array will be like that, if it will create at one value in the 0, so it will become the valid mountain. So here it will be one value will be here. So let's start how we can write the code for that. So for valid mountain, we can see at least we need 3 value. So without 3 value, we can't make a mountain. So values should be at least we should have some value like 2, and here we can suppose it should be 3, and then again if we have value 2 or 1, that is making a valid mountain. So what is the minimum requirement? We need minimum length at least 3. So if our length will be less than 3, then it's not making a valid mountain. So this is our first condition. If this is true, then we just need to return false. This is not a valid mountain. But if this is correct and its length is less than 3, not less than 3, it's more than 3 or at least 3, then we need to initialize the array. So we need to initialize I equal to 0. We have to take one index I, and then we started checking I plus 1 should be less than L. L is the length. So if it is less than L and then array of I is less than array I plus 1, then we have to increase I equal to I plus 1. We have to increase index by 1. If no, then we are going to check I equal to 0, either I equal to 0 or I equal to last value, last index. In that case, if this is the true, then we have to return false. We can't make a valid array using this because it's just a increasing order like this. But we don't have climbing down. But if this is not yes, this condition is not true, then we are going to climbing down condition. We are going to check I plus 1 should be less than L and array of I is greater than array of I plus 1. So this value, so we see here. So this value should be greater. This is the I, this value is the, suppose I plus 1, here I, this is the I, and then this value is I plus 1. So this is the index I plus 1. So if I equal greater than I plus 1, then our condition will be true. So that's why we are defining I greater than I plus 1. So here condition with this, and in this position, if we are going on top, here I should be less than I plus 1. So we need to check these two conditions. Here it should be increasing, here it should be decreasing. That we have to check. We are checking this value, and after completed this loop, while loop, then we are going to check I equal to L minus 1. So if it is the last index, it is the last value of the last index of the array, then we have to return true, either we have to return the false. So let's start writing the code. Here we are going to define, we'll check L. L is the length, array dot length, and then here we are going to initialize I equal to 0. And now we'll check if L is less than 3, then return false, either we'll write while loop while I plus 1 is less than L, and it's we have to check the next value is always less than of the length I plus 1, and array of I is less than array of I plus 1. Then we just need to do I plus plus. If here we are going to check I equal to 0 or I is L minus 1. So if it's last index, this is we are going to check return false, and now we are going to climbing down while I plus 1 less than L length, and array of I plus 1 is greater than array of I is greater than array of I plus 1. Then again we have to return, we are going to increase, so we have to increase I plus plus, and then we just need to check it is the last value. Then what we have to do, we have to check is this is the last array of the index, and then true, then we have to run the code and let's see the result. And all our test case is passed. So here we are checking the 2 1, so it is array size is less than 3, so it's false. And here 3 5 5, so what we are doing, it's just increasing and but not decreasing. So let me explain it. So 3 5 5 like this, 3 5 5, so this value is here only, so we just increasing the value but not decreasing. So 3 5 5 is also not a valid array. And if you take the example of this 0 3 2 1, which we already did the dry run for that, and 0 2 3 1 is the valid array because first is increasing and then it's decreasing. So here it's first increasing, this value is increasing, and then it's decreasing. So this is the valid array example. So I hope you got the point how to get this valid array concept and how to write the code. And if you really like it, please write comment here and then share with your friends or colleague who is interested to writing the code. And then you can, if you have any doubt, you can provide your comment. I'll try to check, or I'll try to explain it more clear way that it will be very helpful for you. So thank you for watching and signing off for now.